Welcome, everybody, to the last part of this wonderful day. This is a panel discussion about data science, about bids, and really about what interests you, hopefully riffing off of what you saw in the last few hours, both in the formal presentations and then what just happened outside at the data science fair. The way we'll do this is I will moderate. My name is Josh Bloom. I'm a professor in the astronomy department and director for the Center for Time Domain Informatics here at Berkeley. I'll first start off, ask everyone to say who they are and introduce themselves and where they work. And then we'll kick it off with a couple of questions from me to get the conversation going and hopefully involve all of you towards the end so we can take some questions and maybe keep the dialogue amongst friends and the internet, whoever is watching. So with that, let me pass the torch.
Thanks, Josh. I'm Katherine Carson. I'm the Associate Dean of Social Sciences, Associate Dean for Research, and I'm the acting director of the new Social Sciences Data Laboratory, DLab, which opened nine months ago.
Great. I'm Mike Franklin. I'm a professor in computer science, and I'm one of the directors of the AMP Lab. And if you might have seen our table, AMP stands for Algorithms, Machines, and People. And the idea is that those are the three resources you need to bring together to make sense of big data.
So I'm Deb Agarwal. I'm at Lawrence Berkeley Labs, and I run a department called Advanced Computing for Science. And so we're working in data science with a broad array of different science areas.
Great. So I wanted to start off with a question about people. One of the three pillars of what we heard in the AMP Lab, what it stands for. We heard today about people as being central to the success of this thing that we call data science. And I wonder if I could get you, Cathryn, to reflect upon where you see people in your own work, in your own lab, as both being important for driving new conversations about data science, for making new discoveries that are enabled by data science, but also more broadly about the role of people in this endeavor.
Yeah. I start addressing that question from the perspective of a domain scientist. That is, from the social sciences, where we have individual investigators, PIs, or in many cases in our domain graduate students who have questions they want to answer. And the challenge that we're facing in BIDS and the challenge that we've faced in DLab as we've built it up is how do you, at scale, provide the tools and the training across those sets of research questions so that the individual who wants to answer a question gets those skills, those tools, that training so that they can run with it? How do they get the resources that serve their individual questions? And this is something quite distinctive, I think, about the social sciences in the larger landscape of academic research, that so much of it is done in small teams and individual investigators who may be in the very process of getting trained. And so it's been really powerful to think through how we can use the fact that one of the great resources of Berkeley is the people here. The graduate students, the postdocs, as well as the faculty, in order to mobilize that resource in both its sort of individualized ways and its collective ways. How to start from the people as the central resource that we bring to it, rather than the technology, rather even than the tools, how to start from the people with the questions they want to answer. So if I were going to answer Josh's question, I would push even more strongly maybe than you would. It's not just people in terms of masses that we can accumulate. It's the individual questions that they bring to it.
Good. So thinking about what happens up at the lab where potentially the size and the scale and the velocity of the data is even larger than what many of us are doing in astronomy or social science and many other of the application domains. How does the size and scale of the data change the resources you need in terms of people, in terms of their capabilities? How do you architect as a leader the interactions that people have to make some of these great discoveries and leverage these incredible resources that we have?
Well, I would say that the number of people you need doesn't scale with the data, right? I mean, you don't suddenly need 10 times as many people if you have 10 times as much data. And it's more that the infrastructure has to scale with it, and the algorithms have to scale. And so you do need some more people to write those algorithms to enable it. But I would actually say that in my experience, it's the complexity of the data that drives how many people and how hard is this, just as much as the scale. And we're actually dealing with both of those domains, and that's really driven the challenge, I think, from our perspective.
Okay, so Mike, what are you seeing as your sort of principal challenges? Obviously, the EECS department is world-renowned for the infrastructure, having created both the hardware and the software and the concepts behind how big data is done. What are the challenges that you're seeing now in getting some great results out of what you built?
Well, actually, I was going to answer the people thing first.
Okay, good.
I could do that.
By all means.
I was trying to figure out a nice way to segue that, but I couldn't quite. So let me do the people thing, and we'll talk about the challenges after. I just wanted to mention, so our view on where people fit into the equation has been, we're kind of two minds. On one hand, we look at individual data scientists and groups of data scientists that are posing questions and trying to get answers to them. But we also do look at people as a potential computational resource. And so we do a lot of work with crowdsourcing platforms and human computation. And the idea there is that there are still a lot of problems, data-driven problems out there that despite all the great advances in algorithms and statistics and machine learning, and despite all the advances in hardware and scalability, there's still problems out there that the technology on its own just isn't quite up to handling. And these are things with ambiguity. These problems show up when you try to take data from multiple sources and put it together and make sense of it. When you try to do certain types of sort of subjective analyses and so on. And so part of what we've been trying to understand at the AMP Lab is exactly kind of the opposite of what Deb said, is we actually have problems where the number of people you need does need to scale as you start looking at more and more data. Because you need to be able to marshal the resources of more and more people to help you make sense of that data. So, I mean, I think it depends on how you look at where people fit in. And I thought Tim O'Reilly earlier brought out that interesting point where he talked about the evolution of going from a visual representation of a map to help somebody find their way around or help somebody drive to in the case he mentioned sort of a self-driving car where the map is actually embedded into the application. And so I think there's going to be this constant evolution of what people are doing in the data processing pipeline and sort of how that flows into the more automated systems.
Good. So, I mean, just connecting back to what you had said at the beginning with the fact that it's people who need to articulate the questions we're asking. We've heard about people as a potential computational tool. I mean, we have these 30 watts supercomputers in the top of our heads that somehow do amazing types of computations that computers have not been able to replicate. For the scale that we've been able to get to, we're not able to replicate the human mind, obviously. One of the things that I've been thinking about is whether we will get to that point where computers are not just this cognitive tool and these amazing artificial intelligence frameworks that people have built, or is not just this thing that's going to help people be smarter in the way that we heard today with Tim O'Reilly and this whole sort of Google Now thing. But whether we're going to get to the point where machines are going to start being able to ask questions that were once asked by people. I mean, in the end, people, we think, still have to write the papers and come up with these results. But I do think back to a bunch of articles, starting off with one in Wired almost 10 years ago, talking about the end of science, the end of hypothesis-driven science and the scientific method as we know, and being completely data-driven, obviously. Gets us some way towards that. Maybe have you come back and talk about the role of people in 5, 10, 15 years where so much of the scientific hypotheses that we're now asked to generate are essentially auto-generated.
I'd love to take a crack at that, but I'm actually more interested in hearing what you guys say first.
Is that fair? Can she do that?
I thought you were the moderator.
I want to hear too.
Yeah. I think we're all looking at you.
Oh, jeez. See, wow. That just threw me right off the question.
Well, so let me ask it maybe in a different way and come back to the view from the AMP Lab about not just the roles of people to do cognitive tasks in this workflow, but the roles of that fundamental role of people to be generating the scientific questions that are the reason why we're doing what we're doing.
So I do want to answer that one.
Okay, good.
Sorry. Because I think the notion that we're moving to a completely data-driven world is not really accurate. I mean, we're moving to a world where we've got a huge amount of data. We've got an unprecedented ability to bring together an amazing amount of data. That doesn't mean we're going to do it model-free, right? You still need the models to understand what you find about the data. So you might do a non-model-driven investigation, but you're still going to formulate a model of why was that the answer, and you're going to have to figure out the interpretation. And we're a long way from having that the machine can actually go beyond just finding sort of random correlations and things like that, or being driven by our own doing the investigation and driving it. And honestly, we're moving so fast where we're doing cross-disciplinary things, cross-scale things that need whole new models that we're a long way from ever being, where the human isn't in the loop, sort of driving that whole process with the models and still that scientific investigation. It's just unprecedented amounts of data that you're driving it with and ability to, in the same way that you would, if you observe something happening in the natural world, you formulate a model and you gather data and you try to interpret what happened. I mean, we're now going to have the situation where sometimes you're going to find out that thing existed in the natural world by the data that you got, and then you're going to formulate the model afterward. And so I think in that respect, I think the people are very much a part of that scientific investigation. But I still want the computer to write the paper for me. More than
All right, we'll work on that. Mike, any perspective on that?
Yeah, it's actually interesting. So our faculty director, Saul Perlmutter, and I were actually having a conversation about this exact topic earlier this morning. And one of the things that Saul mentioned was that he's, well, I don't want to put words in his mouth, he's sitting right there, but tell me if I got it wrong. But he's concerned, or at least interested in the question of if you focus too much on the data, or if you let the data drive the exploration, that you might end up not asking the right questions, or at least not answering the right questions. And so one of the things we were batting around, just as ideas of things that BIDS could be doing going forward, would be putting together some discussion about that basically that trade-off, and in particular, having discussions around cases where kind of focusing on the data too early or the wrong data too early sort of gets you going in the wrong direction. So I think I'm just saying what Deb said a little differently, that it seems that there's going to be obviously some back and forth and some mixed initiative.
But it's also really easy to have artifacts in the data and things that you end up just focusing on,
Yep.
right? And without the model and the processing of that data, right? You have plenty of that in astrophysics, right? Where without having processed that data, calibrated that data, and all those things, you'd find an amazing number of correlations and things, and they'd all be, an airplane went by,
Right.
Things like that. So, if you don't have that model, and if you don't have sort of the idea of what it is that data represents, you run a high risk of finding things that are non-existent.
Yeah, so there's still a role for intuition and history. That's good. Yeah.
I find it so intriguing that we have this conversation trying to nail down what the future can bring. I mean, what? End of science, there was an end of physics conversation in the 1970s that, somehow scientific fields reach these moments where they think that's a useful question to ask. And I would much rather see us build BIDS as this incremental organization to figure out what that future is going to be, rather than make projections now that it must be that there's always going to be intuition, or the other side, that at some point in that infinite distant endpoint horizon asymptotically, that machines will do everything. I don't even understand why that's a useful.
Well, I'll tell you where I'm coming from on that. I would say it is useful in the following way, that we're talking about the commingling of what we might call domain scientists and the methodological scientists, those are building algorithms and new statistical approaches and computational approaches. And if we are heading more towards a data-driven world, and we believe that it becomes more and more of the scientific future, then we have to start thinking about, from an educational standpoint, where are we asking, the PhD candidates in astrophysics to spend their time? Are they going, and taking classes on the infrastructure, the algorithms, and the techniques, or are we asking them to get really, really deep into some of those domain questions? Now, what's interesting is Peter Norvig said this morning, for those that weren't here, that he thought everybody had to become a data scientist, which I thought was, it's a huge statement. One of the things, and this is kind of moving the conversation in a slightly different direction, that we also do here at the Berkeley campus is not just research, but we educate. And I think one of the reasons why we probably want to give some thought to where things are heading is because it also tells us the types of educational tools that we need to bring to the table. So that's I think that's where I'm coming from. Maybe have people reflect upon this everybody needs to become a data scientist thing, which is good probably for all the people in this audience, and adds a huge burden on all of us as educators.
What was your training that got you into being a data scientist? I mean, when you went through undergrad or grad school, was there a curriculum that taught you how to do what you do?
No, absolutely not. I think what people what winds up happening is you wind up waking up one day and go, wait a second, I'm very interested in these domain questions, but I'm also really interested in the methodologies that got me here. Mm-hmm. And the interesting thing is, I think a lot of people who might declare themselves today, probably Peter Norvig included, if he's still here, is the idea that you're sort of taking a classical path until you realize that classical path has gone off in some direction in sort of this new territory. Went through the classical astrophysics, physics kind of track, and recognized to do the kinds of science I wanted to do, I had to be innovating in other aspects that were certainly well outside of my wheelhouse. And I suspect, in a generic way, that's how a lot of you who would consider yourself a data scientist to have gotten to this point. Really, the question from an education perspective is how we sort of do this from the ground up, so it doesn't just fall in our laps and one day everyone realizes they're a data scientist.
Yeah, I mean, from my perspective, it's interesting because I think it was this week earlier that President Obama made the statement that he thought everyone needed to learn how to program. It's Computer Science Education Week, so. But I'm not sure I fully agree with that one, but I do think everyone is going to need to learn how to understand data and how to become literate in data. And I do think that those are just going to be basic skills. Understanding how to make sense of data and how to interpret results that were derived from data, I think, is going to be just basic skills that everyone's going to have to know how to do to some extent.
And there may be different tracks to do that. I do like the idea and the notion around data literacy, in sort of harkening back to what we used to call scientific literacy, that we had to give everyone a core training at the undergraduate level, if not earlier, in how to understand and interpret some of the results. We thought about that as a domain sort of thing. Everyone should understand the basic concepts behind biology so that when you read about it in the New York Times, you sort of get where it's coming from, understand some of the core principles. Now, the thing that we worry about in our students is some of their inability, for lack of training, in how to think about data in the same way. So how does this, do the national agencies, DOE, for instance, take sort of a position on this from an educational perspective, or is it mostly focused on the sort of core science results?
Well, DOE doesn't do so much on the education side. I mean, they're just starting to make forays into that, so. And I really can't speak for DOE.
Okay.
Sorry.
Didn't mean to put you on the spot. Sorry. So I thought maybe what I could do is open up for questions. I'm sure you have a lot on your mind. One of the things that I want to make sure we have a little bit of time to get to is, what people saw out there that surprised them, and how we use what is this very large and very broad attack on data science from all these different directions. How do we leverage what we have right now, and how do we do the next thing in the context of bids? And one of the things that's been kind of on my mind is this question around what our first big wins are in bids, and how should we be moving towards those? So it's a little bit predicting the future, or at least trying to move towards it, but short term. Yes, we have a question over here.
Do you have a mic?
Yeah.
Just on the bottom, yeah.
No.
Press the bottom.
I'll just shout.
Shout.
Okay. So Josh, I just wanted to pick up on your comment about being, at some point in your research career, getting as interested in the science as the methods. That's definitely what took me away from kind of research, or traditional research. I guess if you're following a kind of traditional academic career today, the sort of payback for getting interested in methods is that you might be able to turn that back into churning out more papers later, especially if you're seeking tenure or something. How does this program support researchers who actually say, you know what, I'm not that interested in producing papers, but I am interested in helping others produce research. I just want to spend time working in methods and producing software for research communities. How do you think this program is going to help people who go down that path?
Well, certainly, and I'll have everyone sort of reflect who's been part of bids on where we think we're going with this. But I think just even articulating that as a problem right now, not necessarily just on the Berkeley campus to harp on it, but more broadly, is one of the many reasons that brought Moore and Sloan to the table in recognizing that there was that sort of reward structure for what we'll call alt career paths, and how we find metrics that give us the belief that somebody's doing something transformative. It's just maybe not something that fits into the traditional publish and perish, or publish or perish. So Freudian slip there. There is a good book called Publish and Perish, by the way. It's 3 short stories about academics who die. One of the things, for instance, you take somebody who's building a large open source framework like IPython, Fernando Perez is one of the co-PIs, and how you reward the use of that, the number of scientific papers and results that have been produced because of innovations like his is not something that fits into the traditional model. And so it's something that's on all of our minds, and maybe have all of you talk about how we're trying to work on this and how that becomes more of an exportable model, so you're not just taking it as a person-by-person case, but actually trying to make some generic statements about what needs to happen.
Yeah, because altmetrics has got to be part of the foundation. But look, the part that's really salient to me, sitting as an administrator in Berkeley, is the long march through the institution. That unless we open the conversation inside the academic career path, that doesn't just say, okay, there's these nice metrics here, but this is important and we need to find ways to reward and advance the people who do it. I mean, it's nice to have the numbers, but unless you have the institutional and the political will to fight that battle, it goes nowhere. And so it seems to me that part of the thing I've decided to take on inside BIDS is that challenge. How do you make the case that this is the future of science, and therefore we have to use the altmetrics and all of the other ways of measuring productivity to reward it? Because otherwise, universities have got to change. If this is the direction that science is going in the future, then Berkeley's being great now is not going to be a guarantee of it being great in the future unless we make that change. So there has to be a strong institutional component. And yeah, Moore & Sloan has been really clear that administrative buy-in into this process, that changing notions of faculty careers and reward structures is going to be central to making it succeed. I mean, gosh, how we're going to do that feels to me like the long march through the institution, but that's the thing I find pleasant.
So I'm finding Catherine sort of, sometimes she is willing to try to predict the future.
I know. I was
biting
my tongue.
It's kind of selective here. But,
it's totally...
So I think that's all true, and I'm really glad that we have people like Catherine who are willing to fight the good fight through the administration, and we thank you for that. And obviously we're excited to have the support of the foundations to help us understand this. But I also want to say that one thing we found in our own work, we do a lot of software development, and we are very actively engaged in the open source community. And what we're finding is, despite our best attempts at applying whatever metrics we want to apply, the open source community is applying its own metrics. And what we're finding is that a lot of our students are becoming, in some circles, more famous than any of our faculty. And I've had, yeah, it's okay. I know. But I've had, really funny situations where, I went to a meeting of some of the top data scientists in the Bay Area, and people said, "Oh, you're from Berkeley. How's," and they mentioned some student, and how's some other. I'm like, well, we have all these, Turing Award winners, Nobel Prize winners. They're not asking about any of it. They're asking about, some student in our lab who had built some really popular piece of software. And I've been to meetings with investors who would go down the list just in their minds, naming all of my students and all of the students in the lab, and sort of, are they close to graduation? And so on one hand, this is frightening, as you pointed out. On the other hand, it's a fascinating and a fantastic opportunity. And so, there's basically this whole marketplace of ideas. Open source software is kind of out in front of a lot of these kind of open source types of marketplaces. But, there's this whole new communities for deciding what's good and what's important. And I think as much as we can try to drive that from the university administration, I think a lot of it's going to just come from the outside, too.
And figuring out how to make those get connected. Yeah.
Well, and of course the challenge there is that just because you're popular and doing great stuff doesn't mean that you have to belong to the academic structure as we know it now. People that are being courted by investors, you can imagine, are being pulled away from academia.
Right.
Mm-hmm.
How do we pull those people back in, right? And how do we make the academic setting a home for them?
So I think the first battle we might want to fight, with Catherine leading the way, is actually kind of the inverse of what you said, which is it shouldn't be the case that just because you did something that's incredibly popular, that means that it's bad science. Right?
There.
So let's start there, right? It's okay to build things that people say are useful and that get adopted. I think if we can get down that road, that's good progress.
So I thought I saw a hand in the back over there.
Yeah, my name is Lars. I'm starting my 5th year PhD in social entrepreneurship. So when I first started my PhD, there was this massive battle of if I were going to do quantitative or qualitative research. And then luckily there was a professor from the US who did a summer class in Norway, and he taught the power of combining them. It's like blew my mind, right? So since then I've adopted something called action research, which is basically going out and collecting my own data, but applying more of a distributed level, not just me going out doing stuff. And so I was wondering, what do you think about the future of data science in terms of creating jobs that is more embracing crowdsourcing? So where you can like have people from all over the world, or college-educated people, or PhDs that want to just add to their income, and have them get involved in like big, massive research projects that where there's some money for funneling somewhere, and then through internet, through the cloud, and like massive data processing and whatnot, machine learning, you're able to like have all these people collaborate on solving bigger problems like climate change and all that. What do you think about crowdsourcing as a way of going in that direction?
So, Mike, you were talking about crowdsourcing earlier. I assume that's a different kind of thing than sort of having people go out and solving a very large-scale problem. I thought you were thinking about more as sort of individual cognitive tools in a more prescribed way. What about sort of the more open way of being inclusive? Maybe even the people that are not in the academic setting, but are out there all over the world.
Yeah, I think you're right in the sense that our current work in the AMP lab is definitely on sort of tasks that are a little smaller maybe. But I absolutely agree. I mean, I think the technology is there, and at least if it's not there, can be developed to really allow kind of huge collaborations, and to allow those collaborations to expand sort of beyond the boundaries of traditional institutions. I think there's been a number of sort of citizen science types of projects that have been quite successful. I think it's a great way to go.
Yeah, and of course, there's the platforms like Kaggle or Kaggle that asked people, no matter where they are in the world, no matter what their background is, to solve important data science problems, many of which came from industry, but many which also came from academia. So there are those sort of approaches happening already. Any other questions? If not, I've got one. So, sorry, I had some time to think about this stuff. So we did hear earlier today an interesting statement about the fact that new techniques of approaching data in the context of people and doing data-driven discovery would first come out of academia and then make their way into the commercial world, although I think there was then a sort of follow-up statement, I think Tim OReilly said this, maybe Peter Norvig echoed it as well, that it might be the other way around, that there would be ways of attacking data-driven questions with infrastructure, with people, with machines, that we could benefit from on the domain side, within academia or otherwise. So I was going to ask Mike, and then maybe follow up with Deb, where you see some of those tools that are happening out in the real world, how we could be picking up some of those techniques and concepts and bringing them back into our own work, or whether you maybe believe that it's the other way around, that we're going to figure out ways here to innovate, to do things, and then push them out into the commercial world. There's a little both.
Okay. I think it's pretty interesting in that in recent years, let me start backwards. So it used to be that by far the biggest data, and almost the only place you could find anything that would qualify as big data, was in the sciences. And scientists have been always at the forefront of dealing with data problems, at least at a scale beyond what you would ever see in a commercial environment. That may still be true, but certainly a lot of commercial environments have expanded in the amount of data that they're dealing with. We had a speaker from Facebook last week at the lab, and he started off his talk by saying, "Okay, this is a talk about small data," And system. We have all these systems for dealing with big data, but I'm going to talk about one that we built for small data. And they started talking about how they run it across multiple machines, and finally I raised my hand. I said, well, could you define what you mean by small data? And he thought for a second. He said, well, less than a petabyte. So I said, oh, okay.
There you go.
So there are, so I think what's changed in the last few years is, that in the commercial world, there has been this need for dealing with, large scales of data, and as a result, there's been all this innovation and just this sort of explosion of new technologies and new systems for dealing with data. So, and I think, Deb will speak to this, but I think people that have traditionally done high-performance computing have come to see this as well, and they're trying to figure out how that fits in. I do think there'll always be problems that scientists are dealing with that don't have a direct analog in the commercial world, and so I do think that there's always going to be some difference in the development there, but the gaps are shrinking, I think.
Good, Deb. So what are you seeing as sort of exportable techniques and models from the sort of exascale computing that's happening at the lab?
Well, I guess I was going the other way because as you're familiar with, the whole Magellan work at NERSC was all about looking at some of the commercial products and saying, hey, all this stuff's come out of cloud computing with Hadoop and some of these architectures. People seem to be getting traction. Let's see how far it goes, right? And a lot of the science domains found this really easy to pick up. Even if it didn't fit the problem that well, it was a nice, robust infrastructure that could do something that looked enough like their problem that it's like, ooh, but this thing will manage my thousands of jobs? I can make it look like a map in a reduce. Okay. And I think that's happening more and more, right? These sort of generations of brand new technology that are coming out, that are born in industry, are providing us with opportunities to really look at how we can leverage, a whole new set of technology. That's interesting because it largely didn't start for a long time in academia, and then somebody went off and started their company. It was more natively born from a problem that a commercial company had and they needed to solve, and they solved it, and then we said, oh, we can probably use that, right? And I think we're seeing more and more of that in the data world that we didn't used to see. It really was much more of a following world before, and I think that'll continue to flip because, today most of what we really see the major advances in is all sort of text-based. Whereas so much of science is numeric and a lot more uncertainty in other issues, calibrations, all these things that really aren't part so much of their data. But more and more we're going to see it being part of their data, just because they're already starting to ingest all the satellite data. They're driving their own LiDAR. They're driving their own Google cars all over the place, right? You see all these different data collection efforts happening in many of these companies that are going to start having the exact same types of problems we're having. So I think they'll even digress into a lot of the places where we've sort of said, oh yeah, but science is the only one, sort of taking that forward. So I think we're going to see a lot more give and take going on throughout. And if you'll allow me, I want to say one thing about sort of the career path thing. Because in 20 years at the lab, I've sort of grown up through, we started out relatively applied when I first got there. We moved to being really research-oriented, where, the thing that was most valued was, your research output, your theoretical research output, right? That you were really writing theory papers. And if you wrote something that actually worked, that didn't really, that wasn't that big a deal. And we've actually managed to move back to where it is highly valued, right? I actually managed to somehow get found by you and asked to be on this panel, right? Which, normally I'm like down in the guts making something work, right? So the idea that I'm even up here on the stage is sort of, odd and new. But it's been true. We've slowly moved our organization toward recognizing that in fact our science is starting to literally revolve around having the ability to do these infrastructures and enable these things. That we do fall behind in the science side if we don't do this. And I think in the academic space you have the same ability to do this because people Yeah, industry is a huge lure, and the money is a huge lure. But I have to say, we get people who say, you know what, but I'd rather enable really cool science. And you get that set of people who are willing to, not take that really, amazing job with Google with their free dinners and all the other stuff, and the bonuses, and are just like, oh no, I really want to help discover the next supernova, or change the climate, or change the world in some way. And I think when you enable these the sorts of people who are going to really make that happen, it's really cool. I mean, because we've sort of just starting to turn the corner on having that kind of environment, and it's a blast.
Thank you. Question in the back over there. If you could just wait for the mic.
Hello. I've been interested in research done by Dan Kahan over at Harvard University on motivated numeracy and self-enlightened government in the context of data literacy, and how even individuals with high numeracy are inclined to interpret information in such a way that to protect their cultural cognitive identity. So their political biases or whatever, if it's the same data you present it to multiple people with higher numeracy misinterpret it. And I'm wondering if it's on the horizon with the future of how data science and BIDS is conducted to bring this to the attention of the researchers that are involved.
We're all looking at you.
Let me see if I've got that. So it's an empirical social science observation that, data literacy doesn't exist in any kind of pure form. That the making sense even of what looks like pure straight data is filtered through an entire socially formed matrix of impressions, intuitions, instincts that come out of places that the idea of data literacy doesn't even acknowledge. I would love to see Berkeley as a site where, between the iSchool, between the social sciences, between behavioral researchers, where we can. I told you I was going to be trouble.
You do have the last word, by the way.
Yeah, where we can, put out notions like data literacy and then push back on them and say Berkeley is going to be the place where we challenge those understandings as well. So I love that question. But it has to be this back and forth dialogue and arguing. Otherwise, we make no progress if everyone believes that they know what the answer is. I mean, BIDS is really good for back and forth arguing.
Yes, we're all for data illiteracy. Is that what you're arguing for?
So with that, I want to thank all of you and thank our panelists for a great discussion and a great day. We hope to see you all at BIDS.